Section 2.4, page 1, will now discuss both the product and the quotient rule for taking derivatives. So we've already talked about taking derivatives where we thought of it as consisting of two or more functions, but specifically they were added or subtracted as separate terms. Now we need to talk about taking the derivative of two functions only, not more, and we'll think of them as being multiplied or divided. So we'll start with the multiplication piece, which is called the product rule. If we have a function f and a function g, both of which are differentiable, then the product of f and g is also differentiable, but it consists of the derivative of the first function times the second function that is not a derivative, specifically plus the second function is a derivative and not a derivative of the first. Keep in mind there's lots of variations on this where maybe instead of writing f first and then f last on the right side, some people like to see f first always. So it starts as a derivative and then not a derivative. G starts as not a derivative and then is a derivative, where ultimately we've taken the same right side, but in this case, we have just swapped the order of the two functions. Also, I've even seen people, write the G's first, whatever works for you. But let's go ahead and look at this. Here is the wrong way to do it, maybe not the best way to start with this, but a lot of people look at this problem and say, oh, I see a function x squared and I know its derivative. I see a binomial and I know its derivative. But when you multiply the derivative of each of these, you'll get 6x, and that is not the correct derivative. The reason I know it's not the correct derivative is we don't have to use a product rule in this example. We could multiply the x squared times 3x to get 3x cubed, multiply the x squared times a minus 7 to get minus 7x squared. Bringing the 3 out front with the 3 to multiply to a 9 and subtract a 1 exponent. Bringing the 2 out front with the negative 7 to get a negative 14 and subtracting a 1 from the exponent. We know that the correct answer is the binomial 9x squared minus 14, which is not 6x. Now let's go ahead and look at the formula for the product rule. If I think of x squared as f of x, and my formula says start with that derivative, then I'm going to put that 2x first, but it's multiplied by the original g of a binomial 3x plus 7. The formula calls for a plus. The derivative of the second function, which in our case is just a 3, multiplied with the original first function, x squared. So as I distribute the dark blue 2x to my green binomial, I get 6x squared minus 14x, close to the right answer, but not quite. But when I clean up the second piece and rearrange 3x squared to be 3 times x squared is 3x squared, I have two like terms that add to 9x squared, and I do get the same correct answer. So let's go ahead and look at that one more time, just straight through. I'm given a function, and I think of it as an x cubed for my first function, and its derivative is 3x squared. My second function, g of x, is the cosine of x, whose derivative is negative the sine of x. Because they're multiplied, I see no operator in between, which is an implied product. Then I'm going to start with the derivative of the first function, which I've already figured out off to the side, and the original second function, always plus for this formula. The derivative of the second function, which I had found off to the side, and the original form of the first function. Now, in terms of this first portion on the left of the plus, there's really nothing to do mathematically. And even on the right side of the plus, the only thing really to do is we tend to put x cubed in front, and if I multiply it with a negative, I would be writing negative x cubed in front of the sine of x. Next, let's talk about the quotient rule. The quotient rule looks very similar. If I think of the quotient as some numerator or top of a fraction that's a function, and d for a denominator, the bottom of a fraction that's a function, so long as they're both differentiable, and very importantly, we can't divide by 0, so the denominator cannot be 0, then this fraction can be differentiated where the pattern looks very similar to the product rule, except for we have a minus in between terms, and the denominator is squared, and that is not a derivative. So I'm asked to differentiate y. X as a variable shows up twice, once in the numerator, once in the denominator. So my numerator is just x cubed, not thinking of as a fraction, whose derivative is 3x squared, the same problem we used a few minutes ago. My denominator is the cosine of x, whose derivative is negative sine of x. Remember, I'm not thinking of this as the bottom of a fraction. I'm thinking of this as a standalone function. So following the formula of numerator's derivative first, I'll put the 3x squared, multiplied with, instead of the right side function, it's the denominator function in its original form, cosine x. I need that minus sign in between. The derivative of the denominator we'd already found to be negative sine x, and the original numerator, which was our x cubed. This whole thing is over a giant fraction. Be sure to write that every time. Denominator squared. And when you write cosine squared, hopefully you remember the terminology or notation that the squared can actually go in between the word cosine and the variable. Again, really nothing to clean up to the left of the plus sign. And on the right of the plus sign, maybe I would move the 3x squared out front. But I do this time have a negative times a negative to give me a plus. So I used the formula correctly with the minus sign, but ended up having to have a negative times a negative to get my positive.